Let's take a look at a different type of problem. Below here, I've got 4 different problems, and each one is a multiplication problem being put to a certain power. Like, for example here, 5 times n, or 5n, the whole thing in parentheses to the third power. Or this one, x times y times z, the whole thing put to the fifth power. P times q to the second power, the whole thing put to the third power. Or this one, 6 times g to the third times h, the whole multiplication problem being put to the second power. Now, let's take a look at what happens. What we're going to try to do, just like with everything else, is see if you can't develop the shortcut for yourself. We'll write each problem out the long way, and then see if we can establish a pattern that will help us create some kind of shortcut that we can use in these situations, where we've got a multiplication problem or a product to a certain power. So, let's take this first one. The first one is just saying we've got the multiplication problem 5n, or if I really say it out, 5 times n. And we're going to take that times itself in the parentheses 3 times. So it looks something like this. Now our job here though is to simplify. And so what I think I'll do is, since even though it's parentheses and the multiplication dot, they're using those different symbols, it's all just multiplication. So the commutative property of multiplication says I'm allowed to move things around and order doesn't matter. So what I'm going to do is I'm going to put all these 5s first. 5 times 5 times 5. And then all these variables, 3 of them, n times n times n. And now that I've got the numbers grouped together and then our like terms grouped together, I can just kind of put it all together. 5 times 5 times 5 is 5 to the third, but in this case I can figure that out. That's 125. And then n times n is n to the third power. And there's the simplified version of the original problem. So let's see if you can't do the same thing with the other 3. And we'll start number 2 together. Once again, we've got a multiplication problem, x times y times z, and we're taking that problem times itself 5 times. So if we repeat that, we get something that looks like this. So what I'd like you to do from here is to then take this, and again, since it's all multiplication, I'd like to use the commutative property of multiplication. And in fact, let's just put this down here and start regrouping things. For example, here we've got x times itself 5 times. Okay. Then I'd like you to finish it off. Bring the y's down. How many y's would go here? How many z's? And then collapse it all together. What would this give you as a simplified answer? All right, so complete number 2 and try it out for number 3 and number 4. And we'll talk about it in the next slide and see what you came up with. And more importantly, what patterns did you see and what shortcuts were you able to develop in this situation where we're taking a product or a multiplication problem to a certain power. All right, so let's take a look what you came up with. Now, we already did this one together. We had 5n, the whole thing to the third power. We came up with 125n to the third. What about problem number 2? We started this far along, came up with this, but then by using the commutative property, you would have finished up where all the x's were grouped together, then the y's and the z's, which then you could collapse it back down with exponents and say the answer was x to the 5th, y to the 5th, z to the 5th power. Now how about number 3? Number 3 you had to do all on your own. Let's take a look at what we got here. P, q to the second power, the whole thing to the third power, initially would look like this. Using the commutative property, we could shove a few things around and get this. P times itself 3 times, q times itself 6 times, and we get p to the third, q to the 6th. And the last one, if we did this fourth one correctly, we would have gotten 36, g to the 6th, h to the 2nd. And so of course what our goal here was to try to find a shortcut, some kind of pattern that would help us skip all the stuff in between and go from the question to the answer directly. And so hopefully what you came up with in your own words is something that matches the algebraic definition, which is this. With any product, or what we call a whole multiplication problem, which is what a product is, to a power, you raise each factor inside the parentheses to that outside power. So for example, algebraically, in a textbook, you would see it like this. Here we've got the multiplication problem, or product, x times y, and it's all being put to the power of n. Well, what we do is each of those factors, the x and the y, we put those to the power of n. So we get x to the nth power y to the nth power. And initially you might think, oh, that's distributive property. Well, technically it isn't. It may feel a lot like it, but it is a different situation. So to call it distributive property is technically incorrect. But if you kind of want to think of it as a close cousin to distributive property, and that helps you remember it, then go ahead. So now let's apply it to a few problems. Let's do these two problems without the long way. Let's just use the shortcut so we can get straight to the answer. All right, so here we've got 2 times p times q. We've got 3 different factors which we've identified. So each of those factors is going to be put to this outside power, 3. So 2 to the third power times p to the third power times q to the third power. And if I simplify that a little further, because we can actually do 2 to the third power, 2 times 2 times 2, that's 8. So we get 8p to the third, q to the third. And there's our answer without having to go through it the long way. What about this one? 3 times d times f to the second. Once again, we're looking at 3 individual factors. So each of those needs to be put to the fourth power. So 3 to the fourth power, d to the fourth power, and then f to the second to the fourth power. And I'm going to leave those parentheses there because I've got a double exponent here. But now we can clean that up. 3 to the fourth power, 3 times 3 times 3 times 3 turns out to be 81. D to the fourth is just fine the way it is. And then we just learned about this earlier in this tutorial, a double exponent, f to the second to the fourth. In this situation with a double exponent, we multiply them together, so it becomes f to the eighth. And once again, we go from the question, a little bit of work, to the answer without having to do it the long way by using our established shortcut.